Yes, Sandra? Yes, Sandra? Yes, members? They want us to find the resultant. Let's have a sketch of that. Let's have a sketch of that. X is a positive. X is positive. So our sketch will be like this. X is positive. It's going to be like that. Then Y is negative. Y is negative. Y is negative. Like that. Like that. That's our sketch. Don't forget to put the arrow, please. Don't forget to put the arrow. Don't forget to put the arrow. X is 4.1005 Newton. Then Y is negative 1. You already put the arrow is right. Give me the direction. Now here you just put the magnitude. So it's positive 1.142 Newton. So the direction will be here. The direction of the resultant will be here. Direction of the resultant. Which direction will it take? Direction will it take, members? Going to be like this. Good. F arrow. So F arrow is equals to the square root of Fx squared plus Fy squared. Fy squared. So our F arrow will be equals to the square root of. So when you substitute, what do you get? X is 4.1005 squared plus 1.4142 squared. Just put it once in a calc and see what you get. Put it once. Open a bracket. Open a bracket. 4.1005 close squared plus. Open another one. 1.4142 close that squared equals to. You get then get the square root of that. So you find that easy. And that one will give us. Members, what have you got?
4.3375.
4.3375. Good. What? Newton.
Newtons.
This is 4 decimal place. Whether they have asked for it, members, whether they have asked for the direction or not, just know that it is a vector quantity, which means you must get the direction. Whether it was asked or what? Or not. So just go ahead and find for me the direction. So direction. The direction we said tan theta is equals to Fy over F over Fx. So it implies that theta is equals to the arctan of Fy over Fx. So theta is equals to the arctan of Fy was, what was our Fy? Don't put the negative because now you have already put the direction. So it's going to be 1.4, 1 what? 1 4 what? 2 divided by 4.1005. So our theta will be 1.4142 divided by 4.1005. Tan of that. You get what? 19 point what? 19.0 degrees. For angles you write to 1 decimal place. Angles you write to 1 decimal what? 1 decimal place for calculation. Okay? Brenda? Brenda. Yes, Nalubega.
Yes, teacher.
Is it okay? Is it clear?
Yes.
Okay.
Yes, teacher.
What about Sandra? Sandra, is it okay?
Yes.
All right. Mm-hmm. I think this one now you can do it. Should we take time again doing those ones? Remember? Or we add just one example and we proceed. One example, right?
Yes.
Mm.
Well, I agree.
Then let's just go and look at under questions here. Let's look at questions which are here. Let's just look at exercise here. Which one should we do? Which exercise should we do from there? Number one, number two. There are how many? There are very many questions here. Which one should we do? So let's do number what? Members, which one?
The third one.
Number three, eh? Okay. Question number three. So they're saying forces of 2 Newton, 1 Newton, 3 Newton, and 4 Newton act on a particle in direction of 0 degrees, 90 degrees, 270 degrees, and 360 degrees, respectively. Find the magnitude and direction of the resultant force. Find the magnitude and direction of the resultant force. So which means, yeah, the first thing you must do, members, you must draw the force. The force what? The force what? Diagram. The force diagram. So here they have given in terms of angles. So you must know which one goes where. So they have said we have forces 1 Newton, 2 Newton, 1 Newton, 3 Newton, and 4 Newton acting on a particular particle. So which means 2 Newton is acting 0 degrees. What does it mean? 0 degrees, what does it mean? Members, what does that one mean? Members, what does that one mean, please?
I think it is on X.
Yes, horizontal, no, sir? Is that what? It's horizontal. It is what, eh? Horizontal. So this is Y, this is X. So which means here, along X, we shall have what? We shall have what? 2 Newton. This is 2 Newton. Then 1 Newton, I've said 90 degrees. 90 degrees, which means is what? Acting what? Vertically. This angle is 90. This is the angle we're talking about. So this one is what? This is 1 Newton. Then 3 Newton is what? 270. Remember, why it's going to be 270? This is 90. This is 90. This is 180. 270 is here. Not so? So 270 is here. 270 is here. 270 is there. So which is it? 3 Newton. So they've given the bearing. You know bearing, you move what? Clockwise. You move what? Clockwise. So and 4 Newton, 330 degrees. Where will it be? Here is it. Here is what? Yes, 270, which means 330 is somewhere here. Is here. So that's what 330 is. So this is it, 4 Newton. Members, if from here up to here is 270, what do I need to add to 270? Which means I must add what? I must add what? Which means that angle is what? That angle is 60 to the horizontal. That angle is 60 to the horizontal, or 30 to the vertical. 30 to the vertical. So those are the only thing we need. So we have drawn our first diagram, 3, 2, 1, and then, so the next step is resolving the forces. The next step is resolving the forces. The next step is resolving the forces. Who is that one attending lesson in the kitchen? Resolving forces. Resolving forces. Vertically. Let's start with vertically. So I'll have Fy equals to, remember what is going to be our Fy? Fy, the first one is what? 1 what? 1 Newton, no sir? So it's 1 plus the 4, this one here, this one here, this one, the 4 Newton. So it's acting to the vertical, which means the angle is here to the horizontal. The angle is to the horizontal, which means it must be sine. So plus, because it's still in the positive side of y. So 4 sine of what? Sine of 60 degrees. 4 sine of 60 degrees. Is there any? Is there any that we have left out? That's the one. So which means our Fy is equals to 1 plus 4 sine of 60. What do you get? You get 4.4641 Newton. Members, are we together? Horizontally, Fx. The first one we have is 2 Newton. So 2. Now, members, when you look at this, is the negative side of x. This is negative, which means just say minus 3, minus this 3, minus 3, then minus this 4, which is 4 cos of what? 4 cos of 60. As simple as that. So we shall have Fx equals to, put it in your calculator, 2 minus 3 minus 4 cos of 60. What do you get? We get negative what? Negative 3 Newton. We get negative 3 Newton. So we have resolved the forces. Now, we have to get the resultant. Let's draw the resultant. Y is positive. Y is positive. Like that. Y is positive. Then X is negative. Which means it must take that negative side, which is this. Completing the triangle. Just completing the triangle like that. So this is our Fx, this is our Fy. So where will be the direction of the resultant? Resultant will be here. That is the angle to the horizontal. So our Fr is Fr equals to the square root of Fx squared plus Fy squared. Sandra, are we together?
Yes, teacher.
What about Nalobegan? Any other people having challenges with network?
Yes, teacher.
So Fr is equals to the square root of, we have Fx, which is negative 3 squared plus 4.4641. Therefore, our Fr is equals to, open a bracket, negative 3 squared plus, open a bracket, 4.4641 squared. You get that? Square root of that. What do you get?
5.3785.
Is 5.3785 Newton. So them there, they are seeing that I've got what? 6.77. No. So what's going to be the direction? What will be the direction? Direction theta is equals to just know is arctan of Fy over Fx. That one there's no debating that. So theta is equals to the arctan of our y, which is 4.4641 divided by 3. So theta is equals to 4.4641 divided by 4. Divided by 3. So arctan is what? You get 50. Is 50 what? 56.1. 56.1 degrees. 51.6 degrees. Are we together? That is it. Which one again should we do? Let's do number 7. I think UNEP 2007. Members, I think UNEP 2007. Let's do that one also. Let's do UNEP 2007. The question is saying the body of mass, 6 kilograms, is acted upon by 5 Newton, 20 Newton, 25, and 30, as shown in the figure below. Find the acceleration of mass m. So now let's get that. This is now example number 3 we are doing. That's example number 3. So this is the body. The body is here. Here. This is 5 Newton. This is 5 Newton. This also here. This is 25 Newton. I've given the angle to the particle, which is 20 degrees. Also this one here. It is 20 Newton. I've given the angle here to the horizontal, which is 60 degrees. Either. Yes, members, that is it. Then I've given also here. And there's also this one here, which is 30 Newton. This is 30 Newton. And I've given the angle to the particle, which is 40 degrees. This is 40 degrees. Have you put it down, members? Have you put it down? Members, have you put it down? Nalubega?
Yes, teacher.
Have you put it down? Okay. What about Sandra? Sandra, have you put it down now?
Yes.
All right. Let's work it out. They want us to find the acceleration. They want us to find acceleration. Just know that force is equals to m what? Ma. That one we have already seen it. Where F is a resultant force. This force is a resultant force. So which means for us to find that, we need to know the resultant force. But how do we find the resultant force? By resolving the forces. By resolving the what? The forces. So resolving forces. Resolving forces. Vertically, let's start with vertically. Vertically. So when I resolve it vertically, what shall we have? We shall have Fy equals. Now this side is it positive. We start with a positive. So which means I'll have what? 30. The angle is to the vertical. The angle is to the vertical, which means it's going to be what? Cos, right? 30 cos what? Cos 40 degrees plus 25. The angle is to the vertical, which means it's going to be cos what? Cos of 20. Then this one, which is in the negative side of y, minus 20. And the angle is to the horizontal, which means it's going to be sine 60, like that. Like that. So Fy is going to be equals to, let's feed it in our calculator. So we have 30 cos 40 plus 20, 25 cos of 20 minus 20 sine of 60. So we get 29.1531. Newton. Is that what you have got? Members, is that what you have got as well?
Yes.
All right. Then you go to horizontally. Fx. Fx, the first value of x we have is it?
5.
5 plus so 5 plus 25. Remember, the angle is to the vertical, which means just going to be sine of what? Sine of 20. 25 sine of 20. Now we come to the negative side. Minus 30 sine of 40 degrees. Minus 20. The angle is to the vertical, which means it's going to be cos of 60. So our Fx is equals to, we shall have 5 plus 25 sine of 20 minus 30 sine of 40 minus 20 cos of 60. Members, what have you got? Negative what? Negative 15.731 Newton. Sandra, is that what you have got?
Yes.
What about Nalobega? Nalobega, is that what you have got? Nalobega? Is that what you have got? All right. So that is the components. Now let's get the resultant. So by sketching, our x, what was our x? Our x is negative, and then our y is positive. So which means I'll draw it like that. So this is our Fy. Then our y, our x is negative. Which means it will appear like this. This is Fx. Then completing this diagram, to form for us a triangle. The resultant Fr, which is here, we can call that angle theta. So which means our Fr is equals to the square root of, don't forget to write the formula, don't just quote it, squared. So Fr is equals to the square root of into our x, which is we got negative what? Negative 15.731 squared plus 29.1531 1531 squared. Therefore, our FR will be equals to 15.7331 squared plus 29.1531 plus squared. To get that square root of that will give you 33 point what? 1, 2,
275.
275 Newton. This is for 4 dBs. That's the resultant force. But from force is equal to what? M what? MA, which implies that our acceleration is going to be F over what? Over what? Over M. So, therefore, our acceleration will be force, which we have got 33.1275 divided by the mass. What was the mass? Mass is what?
6 kilograms.
Therefore, acceleration will be 1275 divided by 6. You get 5.5.5 2 1 1 what? 1 3 meters per second squared. This is to 4 dB. Members, have you seen that? Members, have you seen that?
Yeah.
Any question? Any question on how to resolve? Members, is there any question on how we resolve forces? So now the rest, you try out the rest. You try out the rest. Or we add one more question. We add one more. Members, should we add one more? Okay, let's do question number 5. I think this question number 5, let's do it. Let's also work on that. Let's do question number 5. And we end on resolution of forces there. Question number, this is now our number what? This is number 4. This is number 4. That is number 4. They're saying that three forces act on a body of mass 0.5 kilograms of mass. Mass of the body was given to be 0.5 kilograms, as shown in the diagram. Find the position of the particle after 4 seconds. Find the position of the particles after 4 seconds. So that's how I've given it. I wanted to do that because that question looked a little bit unique, but you just know how to should approach it. We have that. Let's sketch that. This one is there, which I've said is 3 Newton. Then we have another one here. This I've said is 6 Newton. Then another one here. This is 1 Newton. It's given us. Members, if you have seen, I've said all of this angle. I think all of this angle, all of that angle is what?
120.
90. Then this one that I've said, that one that I've said is 120. 120. So they're saying find the position of the particles after 4 seconds. So we have to find the resultant, the position which means they want the distance, the position which means they want the distance, the acceleration. Let's find all of that. So solution. resolve forces, vertically, our Fy, what is our Fy? What will be our Fy? Now, members, before even we go and start resolving forces, if they have said all of this angle is 90, which means this angle is what? Which means this angle is 40?
45.
Which means this one is also 40?
5.
45. Good. That angle is 40? 45. Now, if that is true, which means our Fy, this angle is to the horizontal, which means it's going to be 6 what? 6 what? 6 sine
6 sine 45.
Now this is down, right? Minus 1 what? 1 sine of what? Sine of 45. Sine of 45. So what do you get there? So our Fy will be equals to sine of 45 minus 1 sine of 45. So what do you have?
3.5, 355.
35 Newton. Then horizontally, Fx we shall have. What is our Fx? Fx we shall have 3. 3 is only 3 which is on the positive side, the rest are negative. So minus 6 cos of 45 degrees minus 1. This angle would have just given the confusion here. Okay? So minus cos of what? Cos of 45. So Fx will be equals to, what do you get? 3 minus 6 cos of 45 minus 1 cos of 45. What do you get? You get negative what? 1.9497. What? Newton. Is that what you have got?
Yes.
Good. Now, let's find the resultant force. Resultant force. Members, X is positive. I mean, Y is positive. Which means it will be like that. Then Y was negative. So the resultant will be here. With this one here. This one will be like that. Fr. So the angle is theta. So this is Fx, Fy. So Fr is equal to the square root of Fx squared plus Fy squared. So our Fr will be equal to the square root of into, what is Fx? Negative 1.9497 squared plus Y, which is 3.5355 squared. Therefore, our Fr will be equals to 1.9497 cross squared plus 3.5355 3.5355 cross squared, square root of that. What have you got, members? What have you got?
4.0375.
Is 4.0375 Newton. That's the resultant. That is the resultant. That is the resultant. Hmm? So let's also find the acceleration. 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 A is equals to F over what? F over m. So our acceleration will be resultant, which is 4.0375 divided by the mass, which I've said is 0.5. So what do you get? 4.037. 4.0375 divided by 0.5, which is going to give us 8.075 meters per second squared. You see, they have made mistakes everywhere. There's a mistake in that. There's a mistake in that. So also but the question was asking for the position, which means they're asking for the distance. After 4 seconds, after 4 seconds. So what are we going to do there to find that distance, the position? So which means they're asking for the displacement. They're asking for the what? Displacement. So which means here you must remember the equation of motion. You must remember the equation of motion. So how are we going to find that distance? We know the acceleration and we know the force. So how are you going to find that displacement, members? Because they're asking for the position of the particles after 4 seconds. Who can tell us what we are going to do from there? Who can tell us? Members. Members? Am I talking to people? Please, can you talk to me? Sandra, Stephen, Narubega. We want to find the displacement. We want to find the position of the particle after 4 seconds. What are we going to do? Hmm? Hmm?
Teacher, we first get
With the question.
the
With the question of which
final
one?
velocity and the initial velocity.
Do we need all that? Because the particle is at rest. The particle initially is at rest because they're saying acting, which means initially it is what? At rest, okay?
Zero.
Using S equals to what? UT plus I have
The second
8.
equation.
The second equation, using that equation. Using S equals to UT plus, so which means but initially, the particle was at what? Was at what? Was at rest. Initially, the particle was at rest, which means our initial velocity will be equal to 0 meters per what? Per second. Acceleration, we have got, what have we got? We got what? We got 8.075 meters per second squared. So now, which means it implies now our S is equals to, our S is equals to 0 times 4, because time was given to be 4 seconds. Plus I have time our acceleration, which is 0.875 time which is 4 seconds. So our displacement will be, this is 0 plus I have time 8.075 times what? 16. By 2, 1 by 2 we get 8. So therefore our displacement will be 8.075 times what? Times 8. Therefore S is equals to 8.075 times 8.